Hello, grade 11s. Today we're going to be finishing off this exercise 7.12. I'm going to be doing it in two parts. In this part, we're going to be doing number 2, B, C, and E. All right, so if we have a look at question 2b, they're asking us to determine the general solution of each of the following equations and find the solutions which lie in the given intervals. So for question B, they've asked us for sine beta equals 2 cos beta. And this angle beta, they've told us, lies between minus 180 and 180. Now, I just want to have a look at this interval quickly. You guys can see that they've got round brackets here. So that means if one of our solutions comes out to be either minus 180 or 180, we can't have those solutions because the round brackets mean excluded. And you'll notice with some of these intervals, they have square brackets or the round brackets. So the round means you can't include them, and the square means you can. All right, so back to this one here. What I'm going to do here is, because we've got both the same angle for sine and cos, and we don't have anything else weird going on there, I'm going to divide both sides by cos beta. And if I do that, these will cancel. And then sine beta over cos beta will give us tan beta equals 2. Okay. So now we've got it in terms of one trig function, which is good. And now all I do is I go shift tan 2. And that's our reference angle over there. So the general formula, or the general solution for tan, would be beta is equal to 63 point, round off to one decimal place, 0.4, plus K180, where K is an element of the integers. All right, now because they've given us an interval here, we have to find those particular values, okay? So I'm going to start off when K is equal to 0. And if K is 0, I'm just left with beta is equal to 63.4 degrees. Okay. When K is equal to 1, we get here 63.4 plus 1 times 180. And we get that beta is equal to 243.4 degrees. Okay. Now, just to go back to these things, 63.4 definitely lies between minus 180 and 180. So that one is in. 243.4 is bigger than that, so this is not in. So there's no point in me going to K is equal to 2, as it'll be much bigger than that, and it'll be outside our interval. So now I'm going to test when K is equal to minus 1. So I just change this to a minus 1. And we get beta is equal to negative 116 degrees, 116.6 degrees. That is definitely within our interval, so I can have that solution. Now, I'm not going to go when K is equal to minus 2, because if this is negative 116.6 already, if I go 2 times that, which is going to be 360, now minus 360 from that, it's definitely going to be with outside that interval. So there's no point in going further than that. So I'm ready to write up the solution. So beta is an element. Write the smallest to the biggest. So our smallest one here is negative 116.6 degrees. And our next one is 63.4 degrees. Okay, and there's our solution. Now, let's have a look at question C. Just want to see if I'll be able to fit all of this onto one page. I think it's better if I go to a new page. Okay, so we're on question C. They're asking us to solve this. 2 cos squared theta minus cos theta minus 1 equals 0. Okay, so, oh, and they've given us that theta is an element from minus 180 up to 180. Okay, so what we've got here is we've got a cos squared and a cos, and then some constant. So what I'm thinking here, grade 11s, is I'm thinking a trinomial. And as you've seen before, I use my little substitution. I make coses x and sines y. So if I had to make my coses x here, I would have 2x squared minus x minus 1. And now you can see the trinomial. And I can factorize that trinomial. And we would get 2x plus 1, x minus 1. So what I'm going to do now is I'm going to back substitute for my x to be cos theta. So this becomes 2 cos theta plus 1 cos theta minus 1 equals 0. All right. Now, just like any quadratic equation, we have something times something equals 0. I'm going to set both of them equal to 0 and then solve. So this one here would give us cos theta is equal to -1/2, or cos theta is equal to 1. Okay, now to do the general solution for this one here, just go shift cos -1/2, and you get 120 degrees. So this one here, we would get theta is equal to plus or minus 120 degrees plus K360. And then this one over here, we go shift cos 1, and we get theta is equal to plus or minus 0 degrees plus K360. For both of these, K is an element of the integers. But now, because they've given us an interval there, we need to solve for the exact values. So I have to choose values for K. So if I choose when K is equal to 0, just 0, not 0 degrees. Okay, so if it's 0 here, I'm going to have a look at the plus part first. So we get theta is equal to 120 degrees. And then theta is equal to minus 120 degrees. And then for this one here, if theta is equal to 0, if K is equal to 0, we get that theta is equal to 0. Okay, I just want to check all three of these. 120 lies within that interval, negative 120 lies within that interval, and 0 lies within that interval. So those are all fine. Now, if I go when K is equal to 1, so I've got 120 degrees plus 360, you can see that's outside our interval. Minus 120 degrees plus 360, outside our interval. I'm not even going to go when K is equal to 1 for that one. Here, when K is equal to 1, we're going to get 360, definitely with outside that. And it'll be the same for when K is equal to minus 1. So grade 11s, when you're choosing values for K, just have a look and see if I substitute my K value to be whatever. Just see if it's going to go outside your interval, then there's no point in doing it. Just save yourself some time, okay? So I'm ready to write up the solution for this one. So we've got theta is an element, write it from the smallest to the biggest. So our smallest is negative 120 degrees. Next one is 0 degrees. And then the last one is 120 degrees. Okay, going on to question E. Question E is asking us to solve for 1 minus 5 sine squared x equals cos x, where x is an element from minus 360 up to 0 degrees. Okay, so having a look here, I've got a sine squared and a cos, all right? I want to try and get it in terms of one trig function. And I know I can change the sine squared to be a cos squared by using my square identity, we know, for example, that sine squared alpha will be equal to 1 minus cos squared alpha. And I just got that from our square identity. So I'm going to replace that with 1 minus cos squared x. And we get 1 minus 5, 1 minus cos squared x equals cos x. Distribute the minus 5 in and then take the cos x to the other side. Get like terms together and then just arrange it from highest to smallest, okay? So we get 5 cos squared x minus cos x, and that will give us minus 4 equals 0. Okay, so I'm going to use my little substitution again, and this would be 5x squared minus x minus 4, okay? Now, grade 11s, don't get confused with this x and this x. They're not the same. It's just my substitution that I use. Coses become x, sines become y, okay? It just helps us factorize these things a little bit easier. So if we factorize this, we're going to get 5x plus 4 and x minus 1. Okay, so now I'm going to back substitute. So this becomes 5 cos x plus 4 cos x minus 1 equals 0. So we have something times something equals to 0. That means this will be equal to 0, or that will be equal to 0. And we get cos x is equal to negative 4 over 5, or cos x is equal to 1. All right, let's find the general solution for this one. X is equal to plus minus. Take the calculator, shift cos negative 4 over 5. So our reference angle is 143.1, rounded off to 1 decimal, plus K360. And then for this one here, shift cos 1, we get x is equal to plus or minus 0 plus K360, where K is an element of the integers. All right, so now we need to find specific values because we've got that interval over there. So I'm going to choose when K is equal to 0. Okay, so if K is equal to 0 for the minus 1, we're going to get that X is equal to negative 143.1 degrees. For the plus 1, we'll get X is equal to 143.1 degrees. And then for this one, when K is equal to 0, we get X is equal to 0. All right. This one is in our interval. This one is not in our interval. This one is on our interval because we have the square bracket. Okay, that means we can include those bounds. Right, so if I go when K is equal to 1, let's just see what's going to happen here. If K is 1 for the plus 1, we're going to be much bigger than 0. So I'm not even going to bother with that one. If K is 1 for the negative 1, you can see grade 11s, we're going to be bigger than 0. There's no point. Over here, when K is 1, we're going to be bigger than 0. So I'm not going to check when K is equal to 1. If K is equal to negative 1, we will definitely get a solution here with the plus. So that's what I'm going to check now when K is equal to negative 1. And I'm just going to do it on the calculator. So I'm going to test the positive one first, or let's do the negative one first. Negative 143.1 plus minus 1 times 360. And we get X is equal to negative 503.1. Then let's test the positive one. And we get X is equal to 216.9 degrees. And then we test the negative 1 over here, and we get X is equal to negative 360. All right. This one is definitely outside our interval there. This one here, sorry, this is a negative. This one here is definitely within our interval, and this one is outside. All right, so there's no point in me going when k is equal to -2. You can see that if we minus 720 from these, it's going to be well outside our interval there. So now I'm ready to write up the solution. So x is an element. Write it from smallest to biggest. So our smallest one, this one isn't, sorry. Why? Because it's part of our bound. Okay, so we've got negative 360. Our next one is negative 216.9. Next one is negative, this one here, the 143.1. And the last one is 0. And that is our solutions for that. All right, grade 11, stick around for part 2.